Our next keynote speaker, ladies and gentlemen, is Roland Kappner from thyssenkrupp Industrial Solutions AG. The title of his presentation is Hydrogen, a New Vector for Our Future Energy System. The power for e-mobility we were just hearing about has got to come from somewhere. We can either take it from the grid, based on classical power generation with its mix of emissions, or we do onboard generation with fuel cells. For that, a hydrogen infrastructure is indispensable. Since July, Mr. Kappner is heading corporate business development and sales within thyssenkrupp Industrial Solutions AG. Before that, he has been leading GKN Cindermetal's hydrogen activities after he left McPhy Energy SA in 2015, where he was the executive board member and CEO for the group operations in Germany, Northern Eastern Europe, China, and Asia Pacific. From 1999 to 2012, he had various leadership positions in the Siemens industry sector before he started the Siemens business activities for hydrogen solutions as executive vice president. Roland Kappner holds degrees from the Aalen University on Material Science, the University of Manchester on Corrosion Engineering, and the Management Center St. Gallen on Strategic Management. Mr. Kappner, we are anxious to hear what you have to say about hydrogen.
Well, thank you, Michael, for the introduction. I'm not going to tell you about PM parts, and I'm not even talking about cars a little bit. I mean, most of you know about hydrogen because you're firing tons of hydrogen a day for your furnaces as a reducing agent, but hydrogen has a completely different aspect. And at the end of my presentation, I'd like to draw a bridge between what I believe can be an outlook for the future for PM and hydrogen, a very exciting future energy thing. So, climate change, global warming, renewable energies, batteries, we heard about battery electric vehicles, hydrogen fuel cells, energy storage. It's a very controversial and yet immature discussion we're having, and therefore I'm not going to walk you through my presentation with facts, charts, things like that. I'd rather intend to give you an inspirational and hopefully inspiring vision of what could be the future. And I would like to walk you through the last 6 years of my business life, and Michael explained a little bit of my background, which were very exciting. And if you want to talk about hydrogen energy, you need to talk about this Frenchman, Jules Verne, in 1874. At that time, he claimed that water will become a fuel as much important as coal. And remember, at that time, it was the golden age, the Industrial Revolution, where coal was as valuable as gold. And what he said was that water will one day be an indispensable source of heat and light, and the constituents of it, hydrogen and oxygen. Another quote on hydrogen from Frank Zappa. Most probable he wasn't on hydrogen, but on any other substances when he said that. What he said was, there's more stupidity than hydrogen in the universe, and it has a longer shelf life. How smart? Because how stupid is this? And I'm not talking about this ice bear being wrong on his track. I'm talking about the still ongoing academic, political, and to a certain extent polemic discussion about whether we really have a climate problem or not. And do we really understand the sense of urgency? Believe me, some of us do. If you ever have been lately to China, you can feel the impact of climate changes, of greenhouse gases, of carbon loadings in your daily life. But still, it seems to be very far away from our homes. We see it on television. It still doesn't touch us. Our economies are growing, and they're growing fast. They're growing unstoppable. What happens in Asia Pacific, what will happen in Africa, we will grow. The population will grow, industries will grow, and we still are raising uncaptured levels of carbon in our atmosphere. However, carbon is not an evil thing. Once given the right format, it may be evil if you have these twinkly things on your credit card bill, but it's a matter of how to deal with all these things. And let's have a look on nature. Nature has always developed strategies to cope with the cycles of life. For example, photosynthesis is a masterpiece on our Earth, changing carbon dioxide with water into a valuable feedstock, sugar in this case, and oxygen. Since ever, mankind has been able to copy nature and inventing very nice things. And the question for me is, if you look at the carbon loading on our atmosphere, is it something where we again can try to copy nature? Yes, we do. We start to understand and act. Renewables are growing fast, not also in Germany, but everywhere. And the interesting thing is that it was once driven by pioneers, often smiled at. I can remember the first wind turbine not very far from here. It was called Grovian, and people were smiling. What an engineering geeky thing. You know, once it was driven, as I said, by pioneers, then it was driven by fear. Fukushima, Chernobyl. But today, it's driven by economy. We have technologies available right now. We have the scaling effects that renewable energy generation can be as economic as traditional fossil power plants. The problem with renewable energy, it's fluctuating. The sun doesn't shine at night, and we can't influence and predict wind and weather. So in order to have a safe supply of energy in our economies, in our industries, in our private lives, we need to have energy storage. So again, coming back to nature, how can we take up these challenges and bridge and develop strategies how to cope with what we have in front and reduce carbon levels and not wait until they will extinct us? And here comes hydrogen. It's the most abundant element in the universe. Our galaxies are full of hydrogen. Unfortunately, we don't have it freely available on Earth. You have to release it chemically, and I'll talk about that later. It's an extremely high energy density carrier, and the most simplest element on Earth. It's a 300 billion cubic meters per year feedstock in the petrochemical, in the chemical industry. In many industries, like in powder metallurgy, you use hydrogen, and it's produced from natural gas. When you go home and you fire your furnaces with hydrogen, think about, for every 1 kilogram of hydrogen you use, you release 10 kilograms of carbon dioxide. It's a crazy number. Now coming back to our French friend, he was talking about water as a fuel. If you split water by electrical energy, which is a very simple, well-known process, you split water into hydrogen and oxygen. And if you use renewable energy, you can do that carbon zero. So all of a sudden, you're creating a fuel which is sustainable, which is reusable, and which is based on abundant materials, water and renewable energy. Now, coming back to energy storage, to bring that into a context. You know, there's a lot of discussion about how we can store a large amount of energy. The most efficient way today is pumped hydro. Very efficient, very clean. The problem is we have certain limitations from a geography point of view, and this is not going to work for vast amount of energies, and this is where hydrogen comes. On a grid scale, energy storage, hydrogen by far is today the most advanced technology solutions to store these huge amounts. No battery, no pumped hydro can solve the same problem on a size than it is with hydrogen. For example, there's a process called power to gas. You can turn excess renewable energy by electrolysis into hydrogen, and you can inject up to 5, maybe 10% of hydrogen into the gas grid. And you have an existing infrastructure, and you can store terawatt hours of energy. The problem still is, from a commercial point of view, it's questionable. But it is an option. With large-scale electrolyzers, and by the way, this is a thyssenkrupp product, you can also stabilize the grid because you can put electrical load and balance fluctuations in demand and supply. Hydrogen is more. We've heard about alternative drivetrains. Hydrogen is a zero-emission fuel if you generate it from renewable energy. And already today it's firing fuel cell drivetrains. You can question that, okay, we had that before many years, it didn't work. But I believe historically, the shift from fossil to renewable energy and the technology advancements we had in fuel cell components is changing the scene. And we're not talking about cars only. We're talking about buses, we're talking about forklifts, we're talking about ships driving with fuel cells. And if you look at China, there is an increasing action happening with Ballard cooperating with Chinese manufacturers on fuel cell buses. And I promise you they will be much faster than we will ever believe. It can provide electrical energy. Today we already have grid-scale power stations running on hydrogen with stationary fuel cells. But another aspect, and I believe this is one of the most important aspects, with hydrogen created from renewable energy, we can copy nature. We can do something similar what photosynthesis does. We can reduce carbon loads. Just for an example, a steel plant, a typical steel plant is using the same amount of energy the city of Berlin is using every day. And it's producing 2 million cubic meters per hour of waste gases. And about 40 to 45% are carbon carrying. So how can we get rid of that? There's a process we call carbon to Chem right now, where instead of firing these waste gases to produce electricity and release the carbon again into the atmosphere, we turn back the wheel, take the carbon monoxide and carbon dioxide, and make a chemical synthesis with renewable hydrogen and form valuable feedstock like methanol, even gasoline, fertilizers, higher alcohols, polyalcohols, polymers. It's really a recycling approach, and it works. Now, where's the connection between powder metallurgy and hydrogen? It is an intense relationship. Believe me, the last 6 years I've come across a lot of examples. For example, fuel cell components. I'm sure due to the complexity of the flow fields, due to the complexity of manufacturing of it, due to the demands on the corrosion stability, they may and will see powder metallurgy components. 3D printing, heard about that. You know, when we talk about fuel cells, electrolyzers, it will not only be big machines, it will also be micro components. And talking to a lot of colleagues in the past, there is a clear demand of having very complex structures which can be solved by 3D printing. Of course, it's costly, and today no one could envision that this can replace the normal manufacturing procedures, but it's going to happen. It's like the Grovian wind turbine and the wind parks we see today. Hydrogen storage has been mentioned within the car. Today we store hydrogen usually highly compressed. And if you're riding a fuel cell car today, you're riding on a 700 bar tank. And the engineers beyond us, they know exactly what 700 bar is. It's a lot. You know, when I used to fuel a hydrogen car, I always, when I fueled it up, I stood 1 meter behind, thinking I'm safe, but 700 bar is a thing. You can store hydrogen safely in metal hydrides, whether it's magnesium, iron titanium. There's a different set of systems. Again, today, not economic, but there will be niche applications, and I'll show you one in my last slide where it works. It's a matter of continuing research, development, innovation, when it comes to a stage where you can economically apply powder metallurgy to store hydrogen. Water electrolysis. This is the main engine to path a new way for renewable energy, not only into the electricity grids, but on the different routes I have shown you. And water electrolysis needs three-dimensional surfaces, and today already there is a lot of coating, powder metallurgy involved, and the catalysts for the membrane are also based on powder. So, probably a lot of potential. So to summarize, and answering the question, can we follow nature blueprints? I believe yes. It's not going to happen tomorrow. For large and grid-scale energy storage, people think it's going to start 2020, 2025. For fuel cell cars, we're already building stations everywhere around the globe. And just as a reminder, I believe yesterday the congregation of the 16 German states have put out a suggestion in Germany to ban selling internal combustion engines by 2030. Would you expect that from an economy which is based on automotive industry? Radical changes. So my intention was to tell you about hydrogen and how can it change the face of this planet. Hydrogen generated by renewable energy can serve as a fuel for mobility markets, for cars, ships, buses, forklifts, whatever. It can solve our energy storage problems, rather than building big transmission lines or underground transmission cables. And it can also serve industry markets as a renewable and sustainable feedstock, recycling the carbon we are emitting into the environment day by day. So finally, back to the Frenchman. He was dreaming of a submarine sailing 20,000 feet beyond the sea, driven by water as a fuel, and most probably he was thinking about fuel cell propulsion and hopefully about storing hydrogen with metal hydrides inside. And I can tell you, less than 150 years later, we have the technology. So this is a submarine, again a thyssenkrupp product, driving with fuel cell propulsion and having hydrogen stored on board on metal hydrides. So future is closer than we believe. I thank you for your attention. My intention was to be inspiring, be inspired. And our motto is engineering tomorrow together. Thank you.